So welcome in this class. In this session, we are going to discuss about combining the three operators, grad, divergence, and curl. So the heading is combining the operators grad, divergence, and curl. So we'll prove two main results. So the first one, one, given a scalar function or a scalar field phi. Actually, this phi is depending on x, y, and z. Show that the divergence of gradient of phi is given by the gradient squared of phi. So this is a problem. So proof. So we prove by knowing the definition of divergence and gradient. So solution. So we know that gradient of the scalar function phi is given by partial phi partial xi plus partial phi partial yj plus partial phi partial zk. Based from definition. So this implies that, and remember this gradient of phi is a vector quantity, divergence of this gradient of phi, or this vector, will be given by definition of this operator is partial I partial xi plus partial yj plus partial zk dot at this vector here, partial phi partial xi plus partial phi partial yj plus partial phi partial zk. So that's just from definition. And you know this just as a dot product of two vectors. So this will give us, get the product of components, like components. So divergence of gradient of phi would be partial x, and then you multiply by partial phi partial x plus partial y partial phi partial y plus partial z of partial phi partial z. This is just definition of dot product of two vectors. And you see from calculus, this is nothing but definition of the second derivative of phi with respect to x. So partial squared, partial x squared of phi plus partial squared, partial y squared of phi plus partial squared, partial z squared of phi. This is just from calculus. And you see, we had to prove that this is given by this operator. So factoring out phi, then do the same as partial squared, partial x squared plus partial squared, partial y squared plus partial squared, partial z squared. And then we have phi. Remember this divergence of gradient of phi. And you see this is just the definition of the Laplacian operator, grad squared. So i.e. divergence of gradient of phi is equals to grad squared phi. And then we rest our case. So that's how we prove that the divergence of gradient of phi is equivalent to the grad squared of phi. The second proof, relationship between these two operators too, show that the divergence of curl of a vector A is a zero vector. It's actually not zero vector, it's just zero, that's color. So let's quickly prove this. So remember the assumption here that A is a vector defined in 3D. So proof. So we start by defining the curl of the vector A. So let A be the vector A1I plus A2J plus A3K. So let's start by defining this curl of A. So curl of A will be given by the determinant I, J, K, and then partial X, partial Y, partial Z, A1, A2, A3. This just by definition of curl of any given vector A. So if we expand this determinant along the first row, so the sign of this is plus, minus, plus, then we get this will be equals to I vector. So delete this row, delete this column, so we'll have partial Y, partial Z, and then A2, A3 minus J gradient, determinant of, delete this row of J, this column of J, so you'll have partial X, partial Z, A1, A3, and then plus K, delete this row of K, column of K, so you have partial X, partial Y, A1, A2. That's step one. Then step two, we'll have curl of A is equals to I into brackets. So this is just a 2x2 determinant. So we'll have partial A3 partial Y minus partial A2 partial Z minus J. So partial A3 partial X minus partial A1 partial Z plus K partial A2 partial X minus partial A1 partial Y. So that's what we have. So this is our curl of A. And let's go back to the problem that we are trying to solve. So this is one. So we had divergence of curl of A. So therefore, this implies that divergence of curl of A will be, now you see definition of this one is partial Xi plus partial Yj plus partial Zk, and then dot this vector here. So we have I partial A3 partial Y minus partial A2 partial Z. Then remember this one, I can write, open the brackets and then write it plus partial A1 partial Z, and then minus partial A3 partial X. And so this will be I. Remember there's no problem also if I write this I now on the right side. Still the same thing. So I have I here, and then plus, so this will be partial A2 partial X minus partial A1 partial Y. This is K. So that's just, we are just going by the definition. So next step, let's now evaluate this right-hand side. So divergence simply means now we get the product of the components of corresponding vectors. So that's me. That by that I mean, so the divergence of curl of A will be given by, so this partial x, you apply it to this component of I and this other vector. So partial A3 partial y minus partial A2 partial z plus partial y. Now you apply it to this, remember this is j, partial A1 partial z minus partial A3 partial x, this is 3, plus partial z, you apply it to this component of k, partial z partial A2 partial x minus partial A1 partial y. So that's the next step. So next step, let's now simplify the right-hand side. So divergence of curl of A will be, now this will be partial squared A3, then partial x partial y minus partial squared A2 partial x partial z plus partial squared A1 partial y partial z minus partial squared A3 partial y partial x, and then plus partial squared A2 partial z partial x, and then minus partial squared A1 partial z partial y. So let's bring the corresponding terms A1, A2, A3 together. So divergence of curl of A will be given by, so let me bring A3 together closer to this. So I have partial squared A3 partial x partial y, and then this another 3 minus partial squared A3 partial y partial x plus partial squared, okay, then just write this term, minus partial squared A2 minus partial squared A2 partial x partial y partial z so this is 2z, and then another A2 is this one plus partial squared A2 partial z partial x, and then plus this for A1 partial squared A1 partial y partial z minus partial squared A1 partial z partial y. if I may put in brackets, can say this this, then I can write, make this one plus, and then I make this one minus. Okay, even just leaving the way it was negative. Just negative, and then positive the way it was. So this was negative. You see, partial squared A in general, this one is in general from calculus. If we have partial squared, so from calculus, partial squared f partial x partial y is the same as partial squared f partial y partial x. So it means this quantity and this quantity are just the same. So this minus this, we get 0. Minus this plus this, we get 0. This minus this, we get here also 0. So 0 minus 0 plus 0 is just 0. So that is, or therefore, this divergence. So therefore, divergence of curl of A is just a value 0. This from calculus. Why this equals to this, this equals to this, and when you subtract same value, same things, so the same value gets 0. So this is the end of proof. So thank you.